Welcome back. Let's do question 2b. Point A and B in the first quadrant are points on quadrilateral ABCD. We have quadrilateral ABCD. The equation of line DC is given as y is equal to negative 1 over 3x minus 1. That's the equation of line DC. This is line DC. DC forms an angle of theta with the x-axis as indicated. Determine the equation of the line AB if AB is parallel to DC. So we have to remember that parallel lines have the same gradient. And then we say that in the previous question, we say that line DC's gradient is negative 1 over 3. From the equation, remember, y is equal to mx plus c. So meaning that the gradient of DC is equal to negative 1 over 3. Then since DC is parallel to AB, so it means the gradient of AB is also negative 1 over 3. So this is AB and we have a point on AB which is A, and then now we have the gradient. So we can use the coordinates of this point and the gradient to find the equation. So we start with y is equal to mx plus c, and then we substitute the gradient and the point. Y is equal to 10, and then the gradient is equal to negative 1 over 3, then x is negative 3, and then plus c, right? And then 10 is equal to, and then here we have negative 3 divided by 3, we have negative 1, it becomes positive 1 plus c. So meaning that 9 is equal to c. Therefore, the equation of AB is y is equal to negative 1 over 3x plus 9. Right, the other thing we could have done, we can use the equation y minus y1 is equal to m, then x minus x1. And then we substitute our gradient and then the coordinates of A. So y minus 10 is equal to negative 1 over 3, then x minus negative 3. Minus negative 3 would be plus 3. Then if you remove the bracket here, it's going to be y minus 10 is equal to negative 1 over 3 x. We're distributing this. And then negative 1 over 3 times 3 is negative 1. Then y is equal to negative 1 over 3 x minus 1 plus 10. Y is equal to negative 1 over 3 x plus 9.